All right, this is, I think, going to be video 1 of 3 different examples on some double angle identities. So to begin with, there's a little warm-up up here. You have done this in the past, so I'm going to ask that you pause the video for a few minutes and try to work through that particular problem. And when you are done, then you can unpause the video and the answer will show up in just a moment. So pause video. All right, assuming you've completed the warm-up, the correct answer to the warm-up, you would have placed -6, 8 on a coordinate grid, made a little triangle maybe, used Pythagorean theorem over here. I kind of shortcutted a few steps, but you are going to find the radius, r squared, a equals a squared plus -6 squared. If you add these up, you get 100, square root of that, which is 10, so your radius is 10. So our 6 trig functions, and I kind of squeeze things in over here, simplifying some fractions. But so the 3 black answers are for sine, cosine, and tangent of theta. And then these are reciprocal functions in blue, and so I just reciprocated those black ones to get your answer there. So we're going to move on, and that little skill of finding r is going to help, and one of these video lessons at least, so that's why that skill is a little bit helpful. So we are going to look at 2 new identities. They're called double angle identities because look what's stuck inside of here is 2a, and stuck inside over here is 2a in your sine and your cosine functions. Remember that 2 in there is graphically is going to compress your period, and so we have a couple of identities that we can use to help us solve when we have that situation happening. So I do also apologize, my penmanship is quite horrible, and it's even worse with this little pad here. So the first identity is sine of 2a. So the double angle for sine, that is equal to 2 sine a times cosine a, and this a is just any angle. So it could be a theta, then these would be thetas. Could be an x, then these would be x's. And cosine 2a, or the double angle for cosine, is equal to cosine squared theta, and actually I should have put an a in there, minus sine squared a. And because of our Pythagorean identities, cosine squared equals 1 minus sine squared, and sine squared theta equals 1 minus cosine squared. So if we were to make either of those 2 substitutions, it is possible to have a couple of other options for your cosine double angle. So if I were to substitute 1 minus cosine squared in this, you would end up with a -1. And you would have minus a negative cosine squared, so you end up with 2 cosine squared. And again, this is where you have to bear with the quite complicated handwriting that I have. I also might use a different pen next time. Minus 1. Or if we were doing it with substituting 1 minus sine squared here, we could also represent this as 1 minus, and since it would be 1 minus sine squared, and I have another minus sine squared, it would be 1 minus 2 sine squared theta. And again, if I was officially not doing this, or if I was doing this error-free, these thetas would actually be a's. So I'm going to come up here and I'm going to go, oh look, just made that a theta. So my variables all match, and actually looks like just a smudge. These 2 formulas are in your formula booklet and are available during the IB exam. So you don't have to memorize these, you just need to know how to use them, which leads us to our first example, number 1. And I'm going to switch this to maybe just a regular pen because it might look a little bit better. So example 1, I'm giving you that sine of alpha is 3/5, cosine alpha is -4/5, and I'm asking you to find sine 2 alpha, and I'm also asking you to find cosine of 2 alpha. So I'm going to do sine 2 alpha first, and I may have to then erase and go back. So again, if you need to pause this, you can rewind, write down those formulas for sine 2a and cosine 2a. So I'm going to rewrite them right here. Sine of 2a is equal to 2 sine a cosine a. So again, I'm super slow because I don't have my tablet working, and I apologize. And I can now do some direct substitution into this expression because what I know for a fact is that sine of alpha is 3/5. So that can go right here. So this can become 2 times 3/5. And I also know over here, cosine of alpha is -4/5. So again, I put a's instead of alpha, but this would become -4/5. I was copying the formula straight from the notes instead of putting alphas in there. And now I can actually multiply these. But before I do that, I will correctly change these to alphas because I like to be precise with my variables. And now I can come down here and multiply. This is the same as 2/1. So 2 times 3 is 6. Times -4 is -24. And the bottom is going to be 1 times 5 times 5, or 25. So this is what the sine of 2 alpha equals. I've just done it if sine and cosine are both given right there. So if I want to do cosine of 2 alpha, you have 3 choices because we have 3 equations that cosine of 2 alpha is equal to. So I'm just going to use the first one because it's the one that works for me, and you're going to choose which one to use depending on whether you need sines or cosines. In this case, I have both sine and cosine, so I'm going to use cosine squared alpha minus sine squared alpha. So cosine squared alpha minus sine squared alpha. And again, I'm going to do some direct substitution here because I know what sine and cosine of alpha are. Sine alpha is 3/5. So right here, I can plug in 3/5, but it is being squared, so I have to square it. And I also know what cosine of alpha is. It's -4/5, so right here, I can plug in -4/5, but it is being squared, so I have to square it. And in between is a subtraction sign. So if I square this, I get 16/25. And if I square the next door neighbor, I get 9/25. And thankfully I have a common denominator, so I can get my answer of 7/25. And that should be the answer for cosine of 2 alpha. So your job is first to write down this example because for some reason it wasn't printed, and then you're going to pause this video and you're going to try to do this exact same problem, but you're going to do it with the next door neighbor here. So again, pause this, write this down, and it's a you try. That means you actually try it. 1, 2, 3, pause. And hopefully now you have already tried this example and you are unpaused, and here is the solution to it. Again, there's my double angle formula for sine. I plug everything in. You should have gotten 24/25. Cosine double angle, there it is. Plug them in. You got to square them on this one, and then subtract, and you get -7/25. And I'm sorry this was so long due to my pretty bad penmanship. Hope that helped. End of example 1.